Hi, ladies and gentlemen. I want to walk you through how to do your homework on the computer here. So you'll see down here, I have the worksheet that you're using, and here I have your assignment in the classroom and what it looks like. So the first thing I want you to do is to copy down the values here. So 8 kilogram piece of metal, and so I'm actually going to do this like so. So you can watch me do it as I go. So 8 kilogram piece of aluminum metal at 273 degrees Celsius is placed into 3 liters or 3 kilograms of water, and that water is at 47 degrees Celsius. And it says to determine final temperature. And the one mistake here is it actually says aluminum when it's actually iron, right? It's an iron metal. So I'm going to remove that, put iron, and that means I need the specific heat capacity of iron, which is 452 joules per kilogram degrees Celsius. So what are my known values? Well, now I'm going to just switch straight over to this. My known values, I know that the mass of the iron is 8 kilograms. I know the temperature initial of the iron is 273 degrees Celsius. I know that the mass of the water is 3 kilograms. I know that the temperature initial of the water is 47 degrees Celsius. And I know the specific heat capacity of iron is 452 joules per kilogram degrees Celsius. And I know that the specific heat capacity of water is 4,184 joules per kilogram degrees Celsius. What I don't know is the temperature final. That is unknown. And in order to solve that, I got to look for a change in temperature. So change in temperature, I don't know. Equation for change in temperature would be to say, let's say equations that we'll need to use. We don't know energy transferred. So equation for energy transfer is mc delta T. And we should also say that Q of water will be equal to the Q of iron, right? Because the transferred energy from iron goes to the water. So the energy transferred for the water and for the iron is equal. It's the same amount. What gives to one goes to the other, so they're equal. So the formula I'm going to use is going to basically say the mass of the water times the specific heat capacity of the water times the change in temperature of the water equals the mass of the iron times the specific heat capacity of the iron times the change in temperature of the iron. The mass of the water is very simple. We already know it's 3 kilograms. The specific heat of the water is 4,184 joules per kilogram degrees Celsius. And the change in temperature of water, well, the water is pretty cold, 47, and it's going to go up from there. So I'm going to say it's the temperature final minus 47 degrees Celsius. On the other side, the mass of the iron is 8 kilograms. The specific heat of the iron is 452 joules per kilogram degrees Celsius. And finally, the change in temperature of the iron is, it's really hot, so 273 degrees Celsius minus temperature final, right? Degrees Celsius minus the temperature final. Next thing is I got to follow my order of operations, which is PEMDAS. What's in the parentheses? There's nothing I can do there. Exponents are none. Multiplication. I'm always going to do the multiplication on the outside first. So 3 times 4184, which gives me 12552. And what happens when I did that is the kilograms canceled out. Joules per degree Celsius times TF minus 47 degrees Celsius still equals 8 times 452, which is 3616 times